Okay, so let's see. Finally, we get to one that's worthy of your talentedness and giftedness. Okay. Optional. This is not on there. I didn't do one at 10 seconds, but we'll do that as well. Um, Here's the concept, right? What this is going to boil down to is we're going to eventually set up an F equals ma expression, right? We've got this rocket taking off. Oops, that's supposed to be a fin, right? The force upward, we're going to have to figure out, right? And then, of course, we can't forget that the force of gravity is down, right? And kids will do that. They'll just forget that the force of gravity and just say F equals ma, which, I mean, it does, but it's got to be the sum of the forces, right? Okay, so the first thing I'm going to do is I'm going to find the initial mass, right, is 60 kilograms, right? The final mass is going to be 60 minus 48 is going to be is 12 kilograms, right? And that's why, of course, it's going to accelerate so fast because it has less inertia and less weight, right? And then the next thing I'm going to do is I'm going to find the thrust, right? So I'm going to go force times time is mass, change in velocity. So 2.15 per 1 second, right? Okay, so force times 1 is 2.15 times 982. So let's figure that out. It's 2.15 times 982. Don't forget to divide by 1. Okay, that's 2111.3 newtons. Notice it doesn't ask us ever to calculate that, but of course you have to. Okay, so there's our force. That'll be this force, right? Right, and then now we can set up our little F equals ma expressions. Okay, so the initial acceleration. Okay, the force downward, let's see, the force up is 2111.3, and then let's see, 60 times 9.8. 9.81, what is that? 60 times, it's 588.6. That's the force of gravity. So that minus 588.6, right, equals 60 times A. Okay, so here we go. Now we're ready to do maths. 2111.3 minus 588.6 is that divided by 60 is 25.378, so 25.4 meters per second. Not bad, not bad. So that would be an acceleration of a little more than 2 Gs, 2.5 Gs or so. But the pilots would feel 3.5 Gs, right? Because you're already feeling a G for gravity, right? And then the final acceleration, better not be anybody in the rocket for the final one, right? Let's see, at 12 kilograms, 12 times 9.81. I'm finding the force of gravity is what I'm doing. I'm finding this guy, right? Weight is m times g that's the formula I'm using. So 12 times 9.81 is 117.72. Is that right? Wow. Okay. So now I'm set 2111.3. That's the thrust that we got here. Minus 117.72 is 12a. Okay, so here we go. 2111.3 minus the answer I just got is that divided by 12. That's quite a lot. 166.1316666. Sorry. Okay, so I'm going to say 166 meters per second squared. That's about 17 Gs or something like that. The pilot would feel 18 Gs. Pretty sure they're not going to survive that for too long. So we'd have to actually, if this was a manned or womaned mission, you'd have to throttle that engine back as you ran out of fuel. And then all we're going to do to find the acceleration at 10 seconds is we just have to find the mass at 10 seconds, okay? So we know the thrust is 2111.3 at 10 seconds. The weight is 60 minus, or the mass is 60 minus 2.15 times 10. So 60 minus 21.5 is 38.5. So that'd be the mass, right? And then times 9.81, 377, right? So I'm finding this is the weight, that's the force of gravity, and now we're set, right? We go 2111.3, that's the force, the thrust minus the weight, 377.685 is equal to, what's our mass? 38.5 times A. See if we can do this. 2111.3 minus the answer I just got is that divided by 38.5. It's 45.0289, so 45.0. Oh, let's see. For what time? Oh, we didn't answer for what time the engines burn. Oh my gosh. Let's see. If you have 48 kilograms of fuel and you burn 2.15 kilograms per second, time would be 48. We don't really have a formula for that, do we? Divided by 2.15. 22.3 seconds. All right. Yay. Go team.